Let's practice working with numerical and algebraic expressions together. Now, this video and set of practice problems is meant to be sort of a review on a bunch of different types of topics dealing with numeric and algebraic expressions, so hopefully you found this helpful in reviewing all of these concepts together. Also, if you'd like to download a free copy of this blank PDF, you can find a link in the description box below, as well as an annotated or answer key PDF as well. Let's get started. For number one, we're going to demonstrate our ability to use the distributive property to rewrite each of these expressions as a sum or a difference of two products, and then we're going to evaluate it afterwards. Okay, so we're going to show that we can use the distributive property. So for example, for this first one, this 7 really means that there are 7 of these 3's. So we can rewrite this as 7 multiplied by 3. And we're going to add on, we're also saying that there are 7 of these 8. So this is using the distributive property. There's 7 of each of these numbers that are inside here. So it's 7 times 3 plus 7 times 8. Now, if you're going to go ahead and evaluate this thing, then we can say that 7 times 3 here, that's going to equal 21. And then if we go ahead and multiply this 7 times 8, that's going to be 56. So we have 21 plus 56, right? And if we add 21 and 56 together, that's going to be a total of 77. So that would be the value of its expression. For the second one, we have 4 times the quantity of 5 minus 13, or the difference of 5 and 13. Using the distributive property first, we're going to say there are 4 of these 5, so we should go ahead and say that this is going to be 4 multiplied by 5. Then we're going to take away the product here of 4 and 13. Okay, so I'm going to say minus and say 4 times 13. So we have two multiplication problems here. On the left side, 4 times 5, that's going to be 20. So we have 20 minus, and then 4 times 13. You may need to write that on the side here, but I'm just going ahead and say that's going to be 52. And so if we have 20 minus 52, again, that's the same thing as 52 minus 20, which is 32. So 20 minus 52 must be negative 32. So that would be the value of this expression, and we use the distributive property to help us find that answer. For number 2 here, we're going to go ahead and show our ability to use a distributive property again, but some slightly different problems here. We're going to rewrite each of these expressions as a product, which means we're multiplying something. What are we multiplying? It's got to be a GCF and the sum or difference of two relatively prime numbers. Okay, I'll go over that in just a moment. And then we're also going to evaluate or solve it. So right now we have this expression of 32 plus 24. So let's go ahead and rewrite this. We have 32 plus 24. So we need to find out the GCF of these two terms here. So I'm thinking here that 8 could work nicely. So 8 times 4 is 32. 8 times 3 is 24. So 4 and 3 are relatively prime. So that means 8 must be the GCF. So you give a hug to that 4 and 3. So rewriting this expression, we could write this as 8 times the quantity of this sum of 3 and 4, or 4 and 3 here. Okay, so this would be using the distributor property. If you wanted to go ahead and go backwards and distribute 8 times 4, that's 32. 8 times 3 is 24, you'll get the original. So this is all we have to write using the distributor property. Now, if you just want to go ahead and evaluate it or solve it, we can just use the order of operations. So 4 plus 3 is going to be 7. So we have 8 multiplied by 7. Then 8 times 7, that's going to equal 56. Okay. If you want to check that, feel free to go ahead and just add this 32 and 24, that equals 56, so that checks out. For this second one, we have 15 minus 45. So let's go ahead and write 15 minus 45. Let's see what their GCF here is. I think we can start with a 5 times 3, and 5 times 9. Now 3 and 9 are not relatively prime. They have 3 as a common factor, so 3 times 1 and 3 times 3. So this 1 minus 3, these are relatively prime numbers here. And then if we multiply this 5 and 3 together, that would be the GCF. So rewriting this, we can say 15 is the GCF. And then we have a difference of two relatively prime numbers. So 1 and 3 don't have any common factors. Now you could go ahead and distribute 15 times 1, that does equal the 15 we started with. And 15 times 3, that's 45. And then you could solve that, but I'm just going to go ahead and use the order of operations. So 1 minus 3 is negative 2. So you have 15 multiplied by negative 2. And 15 times 2 is 30, so 15 times negative 2 would be negative 30. So this would be the value of this expression, and if you just did 15 minus 45, that would equal negative 30 anyway. Here's number 3. For number 3, we're going to go ahead and evaluate these powers. So we're just going to be just solving these basically. So we have this first one. This is negative 2 to the 4th power. Keep in mind this is negative 2, but it's basically just 4 of these positive 2s. There's only one negative in the front, so be careful with that. Let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is just going to equal negative 16. Okay, as opposed to the second one here, we have negative 2 raised to the 4th power, so that's 4 of these negative 2s, so it's not the same thing as an a, even though they look similar. Now, if we just ignore the negatives for a moment, 2 times 2 is 4, times 2 is 8, times 2 is 16, but a negative times a negative times a negative times a negative is always going to be a positive if we have an even number of negatives, so that's positive 16. For letter C here, we have 0.5 or 5/10 raised to the 3rd power. So that's really 0.5 times 0.5 times 0.5. Okay. Now, what is 5 times 5? Well, 5 times 5, that's going to be 25. And then 25 times 5 is 125. And how many decimal places are there? Well, there's 1, there's 2, and there's 3. So our answer here has got to be 0.125 or 0.125. And for letter D, we have 2/3 raised to the 5th power. So that means we have 2/3 multiplied by itself 5 different times. So we're going to have 5 of the same fraction. In the numerator, if we go ahead and multiply this, we're going to see this is going to be 2 times 2, which is 4, times 2 is 8, times 2 is 16, times 2, that's going to equal 32. That's going to be the numerator. In the denominator, we have 3 times 3, which is 9, times 3 is 27, times 3 is 81, times 3 is going to be 243. Okay, so that would be the value of this power. Our original expression here is negative 3x plus 8 minus x minus 5. And so before we get started, it's important to know what the terms are. So we have negative 3x plus 8. Remember, they're separated by plus signs. We're going to write plus negative 1x. I'm just going to write the coefficient in case you may forget it. And instead of writing minus 5, we're going to add the opposite of 5. Okay, so we're going to go ahead and rewrite this so it is a sum all the way across. So we have each of our terms here separated by plus signs. So we have negative 3x, that's going to be our first term. And then we're going to have a positive 8 for our second term. We have a negative 1x for our third term. And then we have a negative 5 for our fourth term. Now, which ones are like each other here? Well, this negative 3x and negative 1x, they're like each other because they both have x. So negative 3x and negative 1x. Again, you can write the 1 or not, it's up to you. And then we also have 2 of these normal numbers or integers. That's going to be 8 and negative 5. Those are also like terms with each other. Now, what are the coefficients? Coefficients are just the numbers that are multiplied by variables. So we have negative 3 as a coefficient. We also have negative 1 as a coefficient. Okay, so keep in mind that that negative 1 sometimes people forget. And then for our constant terms, these are just the terms that don't change in value. So 8 and negative 5 are terms that stay the same. So 8 and negative 5 are our constant terms. For the variables, there's only one variable in this expression, and that's just going to be x. You can see it appears a couple times here, here, and here. So the variable for this expression is x. For the simplified or simplified expression here, we can go ahead and combine like terms. So negative 3x plus negative 1x combined is going to be negative 4x. Okay, and then we can also combine the like terms that are constant terms. So 8 plus negative 5, that's going to equal positive 3. So we're going to say negative 4x plus 3. This would be the most simplified expression. For number 5, the statement here is saying, or the question here is, which algebraic properties, so we're looking for more than one, state that you can change the grouping in an expression, but the value remains the same. Okay, so what tells us that we can change the grouping in a problem, but the answer is still going to stay the same? And then we're also going to provide an example of each one. One of the properties we can write here is the associative property of addition, which just states that you can change the grouping when you have an addition problem and it keeps the same answer. So an example you could write here is maybe something like 4 plus 3 plus 9. But when you have this problem, maybe the 4 and 3 are grouped here. And if you wanted to show that this is the same thing with different groupings, you can say 4 plus, but then put the 3 plus 9 in parentheses instead. So we change the grouping, but the answer to this problem would be the same irregardless. On the left side here, 4 plus 3 is 7. 7 plus the 9 would be 16. on the right side here, you can see that 3 plus 9 would be 12, and 12 plus 4 would also be 16. The second property we can state here is the associative property of multiplication. So very similar here, but if we have something like 7 multiplied by 3 multiplied by 5, and we had maybe the 3 times 5 grouped here, we could regroup this instead if we wanted to and say 7 times 3 first, and then multiply by 5 afterwards. So on the left side here, 3 times 5 is 15, 15 times 7 is 105, and on the right side here you can say 3 times 7 is 21, 21 times 5 is also 105. So no matter if you change the grouping, if it's all multiplication, this will get you the same answer even if you change the grouping. Here's number 6. For number 6, we're going to be trying to write some algebraic properties here that state that you can change the order in which we are solving an expression here, so that the value is going to still stay the same though, and we're going to provide an example. One of the properties would be the commutative property of addition. So for example, if you had something like 3 plus 4 plus 6, you could also say the same thing as maybe something like 4 plus 3 plus 6. So just going from left to right, if you said 3 plus 4 would be 7, 7 plus 6 would be 13, or if you said here that 4 plus 3 would be 7 and 7 plus 6 is 13, either way, you would still get the same answer. So we changed the order, but the answer would still be the same. And then we have a second commutative property, this time for multiplication. So in this case, we could have something like, 5 multiplied by 7 multiplied by 2. You could also say that the same thing as 2 multiplied by 5 multiplied by 7. So you can see we changed the order here. On the left side, 5 times 7 is 35. 35 times 2 would be 70. Or we can say 2 times 5 is 10. 10 times 7, that's still 70. So this is the commutative property of multiplication. For number 7, we're looking for the algebraic properties that state that you can perform an operation to an existing expression, so one that's already there, and the value is going to remain the same. So just like the last few, we're then going to provide an example. First, we have the identity property of addition, which states that you can add 0 onto an expression and it will not change its value. So for example, you could say something like this, where you have x plus 0, and that would still equal x. So that would be an example of using the identity property of addition. Then there's the identity property of multiplication. So the only number you can multiply in the world where the expression would still stay the same is going to be 1. So for example, if you said 1 times y, that would still equal y, just because 1 times anything would stay the same. So we have the identity property of multiplication. All right, here is number 8. For these following problems, what we're going to do is we are going to simplify each of these expressions as much as we can, okay? For number 8, let's go ahead and simplify some algebraic expressions here. So for A, it looks like we have x plus x plus x plus x plus x. So think about what their coefficients are. Remember, this is really 1x plus 1x plus 1x plus 1x plus 1x. So that should be a total of 5 x's here, right? That would be the most simplified expression. For B, we have 2x plus 5 plus 4x plus 8. So if we look at these terms here, 2x and 4x are like terms. You can add those together, and if we do that, we're going to get a total of 6x by adding their coefficients together. And then if you take a look at the constant of 5 and 8, we can add those together, and 5 plus 8, that's going to equal 13. So that would be the most simplified expression. For C, we have negative 2x plus 7 minus x minus 13. So it might be helpful to rewrite this as negative 2x plus 7, and you can say this is going to be plus a negative 1x, and then plus a negative 13. This way you can see the terms a little bit more clearly. So what are the like terms? Well, we have negative 2x plus negative 1x. That should be a total of negative 3x, right? And then if we took a look at the constant terms, we have 7 and then adding a negative 13. Well, 7 plus negative 13, that's going to be what? Negative 6. So we're going to go ahead and write plus a negative 6. But if we want to simplify this completely, we can go ahead and say this is going to be negative 3x, and then we can say minus 6 instead. So this would be the most simplified expression here. For letter D, we have 3 times the quantity of this 2x minus 5 plus 6 times the quantity of x plus 2. Let's go ahead and distribute this 3 to both of these terms over here. So 3 times 2x, that's going to be a total of 6x. Then 3 times this minus 5 is going to be minus 15. And then if we go ahead and distribute this 6 to this 1x and 6 to this 2 over here, 6 times 1x is going to be 6x, and then 6 times 2 is going to be 12. Let's go ahead and combine some like terms here. So we have 6x plus 6x, that's going to be a total of 12x. And then for our constant terms, we have, let's see, this is technically a negative 15, right? If we keep change and flip. So it's a negative 15 and a positive 12. So negative 15 plus 12 is going to be a negative 3. So we can write plus, and this would be a negative 3. And then if we go ahead and simplify this a little bit more, we can say that this would just be 12x and then minus 3. So technically it's a negative 3 as a term, but this is a more simplified way to write the expression. For e, we have negative 4 plus x. I'm going to say this is plus a 1x. And then we have this minus 3 times the quantity of 2x minus 5. Now I would just be careful of this minus sign right away. Again, this might be helpful just to rewrite this. So negative 4 plus 1x. And instead of writing minus 3, let's write plus a negative 3. And then that's going to be times the quantity of 2x minus 5. So the reason why I want to do that is make sure that we distribute the correct value. It's not a 3, but technically it's a negative 3. When we do that, we're going to have, let me just scroll down a little bit, negative 4 plus 1x, and then plus, what is negative 3 times 2x? That's going to be a negative 6x. And then we have a negative 3 multiplied by a minus 5, so that's going to end up being a positive 15 here, right? You can write minus a negative 15 if you want, and then rewrite plus 15, and that would be okay too, just an extra step. Combining some like terms, we can add these coefficients of 1 and negative 6. If we do that, we're going to get negative 5x if you combine those. And then if we combine these constant terms of negative 4 plus 15, negative 4 plus 15 is going to be a positive 11. All right, so that would be our most simplified expression. All right, let's move on to this next problem we have in number 9. So we're going to go ahead and evaluate, which means solve, but we're going to be just dealing with numerical expressions. So no variables or anything, and just doing the order of operations. So for A, we have 14 minus 18 divided by 3 plus 2 to the third power. The exponent or the power is going to go first here. So we have 2 to the third power. That's 2 times 2 times 2, which is 8. So we have 14 minus 18 divided by 3 plus 8. Okay, and then out of these options here, this division is going to go next. So 18 divided by 3, that's going to equal 6. So we're going to have 14 minus this 6 and then plus 8. And then between subtraction and addition, they're equally important, so go from left to right. 14 minus 6 is equal to 8, and then 8 plus 8 is going to equal 16. All right, so that would be the value of this expression in A. For B, we have this 32 divided by 8 times 2 plus 8 times the quantity of this difference of 15 and 9. So first things first, let's start with the grouping symbols. Let's start with the parentheses. So 15 minus 9 is going to equal 6. So we're going to have 32 divided by 8 multiplied by 2 plus 8 multiplied by 6. You can keep the parentheses if you want, if you'd rather use that. Out of these options here, division and multiplication are equally important, so we'll just go from left to right. So 32 divided by 8 here, that's going to equal 4. So we have 4 times 2 plus 8 times 6. And it looks like we have 2 multiplication problems and an addition problem. Let's go ahead and do the multiplication on the left here. 4 times 2 is going to be 8. We have 8 plus 8 times 6. Between addition and multiplication, we should multiply here. 8 times 6 is 48. So we have 8 plus 48, and then 8 plus 48 is going to give us a final answer of 56. All right, here is C. For C, we have negative 28 divided by 7 minus 5 times the quantity of 3 minus 5, all raised to the third power. So let's start with the grouping symbol here. So we have 3 minus 5. 3 minus 5 is going to be negative 2. So we should have negative 28 divided by 7 minus 5 multiplied by this negative 2 raised to the third power. Now between all these options here, we should complete the power, which is negative 2 cubed. Now negative 2 to the third power is negative 2 times negative 2 times negative 2, which is equal to negative 8. So this would be negative 28 divided by 7 minus 5 times this negative 8. Okay, And let's see here, we have division, subtraction, and multiplication. Division and multiplication are equally important, so we'll go from left to right with that. Negative 28 divided by 7 is equal to negative 4. So we have negative 4 minus 5 times this negative 8. And between subtraction and multiplication, we're going to do the multiplication here. So that's going to be 5 times negative 8, which is going to be negative 40. So we'll have negative 4 minus a negative 40. Now, if we want to rewrite this as an addition problem, that probably is a little bit easier to read and understand. So instead of saying negative 4, take away negative 40, we can say negative 4 plus 40. And negative 4 plus 40 is going to equal 36, a positive 36. For D, we have a fraction, so we have negative 8 minus the product of 3 and 2, all divided by 2 minus 3 to the second power. So keep in mind that there are invisible grouping symbols technically on the numerator and in the denominator, and that this fraction bar means division here. Okay, so if we rewrite this, we can say that from left to right, we're going to have the quantity of this negative 8 minus 3 times 2. That's going to be the numerator, right? And that's going to divide by the denominator. And the denominator here is going to be 2 minus 3 to the second power, right? So this would be the same expression just written from left to right. And we can perform one thing from each parentheses at the same time. So in the first grouping, let's do the multiplication first here. So 3 times 2 is going to be 6. So we're going to have negative 8 minus 6. That's going to be in the first grouping here. And then in the second grouping, we have 2 minus 3 squared. Let's do the 3 squared. 3 squared is 9. So we're going to have 2 minus 9. Okay, so that's going to be the new denominator here, or the updated version. Now we can just go ahead and take this negative 8 minus 6. Hopefully you know that's negative 8 plus negative 6 if you add the opposite instead. Negative 8 plus negative 6 would be negative 14. So we have negative 14 divided by. And then if you do what's in the second parentheses, 2 minus 9 is the same thing as 9 minus 2, which is 7, but it's going to be negative 7 instead. Okay, now what is negative 14 divided by negative 7? That's going to equal a positive 2. Here's number 10. For number 10, we're going to go ahead and evaluate some more expressions, but this time they are going to be variable or algebraic expressions instead. So we're going to have to make some substitutions. Keep in mind that it looks like A is going to equal 3, B is going to equal half, C is 3/4, and D is equal to negative 6. So these are the values of the variables here. Okay, so let's go ahead and start this off. We have 4D, which is 4 times whatever D is. Now let's make a substitution. This is 4 times, and this is going to be negative 6. And then plus, then we have 9 times whatever A is. Looks like A is positive 3. Okay, so we have 2 multiplication problems and an addition problem. Because we're going to end up doing the 2 multiplication problems back to back, let's just do them at the same time here, but feel free to do them one at a time as well. 4 times negative 6 is going to be negative 24 plus, and then 9 times 3 is going to be 27. If you do negative 24 plus 27, that's going to equal a positive 3, and that would be the value of this expression. Okay, taking a look at B, we have 10B plus 12C. So we have 10 times whatever B is. So let's see, we have 10, what's B? Looks like B is half. So let's go ahead and write it, that's going to be a half here. And then plus 12 times whatever C is. Looks like C is going to be 3/4. Okay, so let's go ahead and do maybe both multiplication problems at the same time here, so we don't have to do too many extra steps. 10 as a fraction is 10 over 1 times 1 over 2, plus 12 as a fraction is 12 over 1 times 3 over 4. Okay, so we're still doing each of these at the same time here, but on the left side, let's see if we can do any cross canceling. I think this 2 and 10 can cross cancel to make 5 and 1. So on the left side, this is all just going to equal 5. And then when we go ahead and multiply these fractions here, the 4 and 12 should cross cancel here. So that should be a 1, that should be a 3. In the numerator, 3 times 3 is 9, so we're going to get 5 plus 9 here. And then 5 plus 9, that's going to equal 14. All right, so let's take a look at C. For C, we have D times the quantity of B divided by C plus 4A, or 4 times A. So what's D? Well, D, we said, or we know, is going to be negative 6. So it's going to be negative 6. That's going to be multiplied by, let's see, what's B? Well, B is going to be 1/2. So we'll go ahead and substitute in, that's going to be 1/2 divided by what's c? Well, c we knew is 3/4. I'm going to go ahead and write 3/4 here. That's going to be all in brackets here, or bigger parentheses if you want to write that instead, plus the product of 4 and a is going to be 3. Okay, let's go ahead and start with the grouping symbol of inside here. So this is really just 1/2 divided by 3/4. I'm going to go ahead and just write this on the side here. This is 1/2 divided by 3/4. If you go ahead and turn this into a multiplication problem, if you keep, change, flip, or multiply by the reciprocal, this is 1/2 times 4/3. We can cross cancel this 2 and 4 to make 1 and 2. So if we multiply this out, 1 times 2 is 2, 1 times 3 is 3, so this is 2/3. Next step here, we're going to have -6, which I'm going to write as -6/1, and then multiply by this 2/3 that we just got here. So hopefully that makes sense. I rewrote -6 as a fraction, just because I know we're going to have to multiply those in a moment. And I'm going to write 4 times 3 using a dot because it's a +3, so it's just a little bit less writing here. Now let's go ahead and multiply these two here. If we cross cancel, we can see here that this 3 and -6, you can divide them both by 3, they're GCF. If we do that, we're going to get 1 and -2. -2 times 2 is going to be -4/1, which is -4, so we're going to have -4 plus, and since these are both multiplication problems, we can do them at the same time. So 4 times 3, that's going to be 12, and then -4 plus 12 is going to be a +8. One more for D, we have the quantity of the opposite of D minus 7 all raised to the 10th power plus 20 times the quantity of the sum of B and C. So let's go ahead and make some substitutions. So first I'm going to use brackets here because we're going to make some substitutions in. So we have negative, and what's D? Well, D is -6, so we're going to substitute in a -6 in for D. Then we're going to take away 7. And this whole thing is going to be raised to the 10th power. Then we have plus 20 times, let's go ahead and use brackets again because we're going to make a substitution. B is 1/2, so let's go ahead and use parentheses to substitute that in, plus C, and it looks like C is 3/4, so let's go ahead and put in 3/4 in for C. So we're adding these two fractions. Inside this first grouping symbol, we have the opposite of 6, which is really just a regular 6. So it's not really an operation, I guess. Maybe you can think about it as -1 times -6, right? There's an invisible -1 in front. I'm not going to rewrite this whole problem though, but that's going to be 6 minus 7, and then 6 minus 7 is going to be -1. So I'm going to go ahead and just turn this into a -1 raised to the 10th power. Okay, so again, the opposite of 6, this is end up being a +6, and a +6 take away 7 is going to be -1. Okay, so hopefully that makes sense. If you want to write in 2 steps, feel free, but I think it's okay just because the opposite is just a regular 6. Okay, and then we have another grouping symbol, so we can perform what's inside here as well. I'll keep brackets here just to keep things consistent. Let's go ahead and add this 1/2 plus 3/4. If we need common denominators, 1/2 is the same thing as 2/4. So if we have 2/4 plus 3/4, that's going to be a total of 5/4, right? Because they need common denominators. So that's going to be times, let's see, 5/4 if you put those together. Okay, so we have a power, addition, and multiplication. Let's go ahead and do the power first. This is -1 times -1 times -1. So there's 10 -1s multiplied together. That's going to be +1. So it's 1 plus, I'm going to write 20/1 times 5/4. Between these two operations, let's go ahead and do multiplication here. 20 and 4 can cross cancel, so we can divide this by 4 and by 4. We're going to get 1 and 5. On the top, 5 times 5 is 25. On the bottom is 1, so it's 25/1, or just 25. So 1 plus 25, and that's going to equal 26. Let's see what else we got here. For number 11, we're going to go ahead and write some verbal sentences. So we're going to write some words out that represents each of these algebraic or variable expressions. And we're not going to be using the words add, subtract, multiply, or divide. For A, something you could write is the sum of some number x and 8. You could also write something like some number x increased by 8. You can also say something like 8 more than some number x. There's many correct answers you could write here. You could say some number x increased by 8. So those are all good answers that you could write as well. I just wrote down one possibility. So you can feel free to think if it makes sense what you wrote, or just run it by maybe a friend or a classmate, or you can leave in the comments down below if you're wondering if what you have works or not. Okay. For B, we have 2y minus 4. So what could we write for a verbal sentence? For this one, we could write something like 4 less than double a number y. You could also say something like 4 fewer than double a number y. Or you can say maybe something like the difference of the product of 2 and some number y and 4. Again, there's several different answers you could write here, but those are just a few examples. For C, we have this expression of the quantity of x plus 5 divided by 6 on the bottom. So let's see if we could write this a little bit more clearly. For this one, we could write something like the quotient of 5 more than a number x and 6. So that numerator is 5 more than a number x, and then we're dividing it by 6, so that's the quotient part. You could also say something like the quotient of the sum of some number x and 5 and 6. Kind of have like a little pause for where that comma would be. But the idea here is that you want to make sure you are adding some number x and 5 together first, and then we are dividing by 6 seconds. So how you say it is important so that we can understand what you're trying to say. Here's number 12. We're going to go the opposite direction now. So we're going to go ahead and write some algebraic expressions that represents each of the verbal sentences. Okay, so for 12a here, we have the difference of some number x and 9. We should write something like this. So the difference means subtraction, so it's going to be x minus 9. For b, we have the quotient of the sum of 3 and some number y and 4. So let's see here. We have quotient, meaning we're dividing. What are we dividing? Well, it's going to be the sum of 3 and some number y. So we're going to have 3 plus y. And then that whole thing is going to divide by 4. So you could write it like this and then divide by 4 afterwards. You could also write this, though, where you write 3 plus y in the numerator, and then the parentheses is implied, right? So we're going to have the sum of 3 and some number y, and then divide by 4, because that's where the quotient comes into play. For C, we have 7 more than the product of 8 and some number c. So we're going to be adding on 7 to something. So the product of 8 and c should just be written as 8c, where 8's the coefficient. And it's 7 more than that, so we have to add on 7 afterwards. All right, for number 13, let's go ahead and see if we can go ahead and identify which of these algebraic expressions are equivalent to the given algebraic expression. So the ones that are the same or have the same value. Okay, so let's see this original one here. We have negative 4x plus 11 minus 4x minus 35. Rewriting this one as a sum, let's see, this is technically going to be negative 4x and then plus 11. Instead of writing minus 4x, we could write plus negative 4x. And instead of writing minus 35, we can write plus a negative 35. All right, so which ones are like terms here? Well, we have negative 4x and negative 4x. That's going to combine here to make a negative 8x, okay? And then if you take this 11, this positive 11, and you take away 35, or you add a negative 35, that's going to be a negative 24, so minus 24. So this would be the original expression, and we're trying to see which one of these expressions down below match it. Right away, you can actually see that C does match perfectly. This negative 8x minus 24, we actually have that right over here, so that one's good to go. If you look at A looks like it's simplified. We have 7x minus 39. You can see here that these coefficients do not match, and also the constant terms do not match. So we can know right away that these are not the same expressions. Similarly for B, you can notice that this coefficient of 8 does not match this negative 8, and this negative 24 does not match this 46, so these are also not equivalent expressions. For D, let's go ahead and rewrite this, so let's distribute to see what we get. So if we have negative 4 multiplied by 2x, that's going to be a negative 8x. And then we have a negative 4 multiplied by a negative 6, so that's going to be a positive 24. So that's super close. We do like this negative 8x and negative 8x, that matches. This says positive 24 though, and this says negative 24, so that does not match. For E, we can go ahead and distribute this negative 8, so negative 8 times x, or 1x, that's going to be negative 8x. and a negative 8 times positive 3 is a negative 24. So hey, that's actually what we wanted, negative 8x minus 24, negative 8x minus 24. So this is an equivalent expression. For f, let's go ahead and simplify this. So combining some like terms, maybe we could try to remember here that this is negative 10x. I'm not going to KCF or add the opposite right now, but keep in mind this would be a negative 10x. Negative 10x plus 2x, that's going to combine to negative 8x. And then this negative 28 plus 4 is going to be a negative 24, so minus 24. So this one does indeed match the original expression, because we can see here that this negative 8x minus 24 matches this negative 8x minus 24. Here's number 14. We're going to go ahead here and fill in the table. So we're going to fill in the blanks here. We're given an expression, so you can see that the expression here is going to be this 3x minus 8 we're going to keep using. And we're given different values of the variables, and we need to make sure we are showing some detailed work here. Okay, so for this first one, x is going to be negative 6. So let's take that negative 6 and substitute it into this expression here. So it's going to be 3 multiplied by this negative 6. And then we're going to go ahead and take away 8 afterwards. Multiplying 3 times negative 6 is negative 18. Negative 18 minus 8 is negative 18 plus negative 8. And negative 18 plus negative 8 is negative 26. So let's go ahead and put that in this empty box here. Now moving on, let's say now x is negative 3. Let's substitute negative 3 into this expression. So it's going to be negative, let's see, it's going to be 3 multiplied by this negative 3. And then we're taking away 8. So multiply first, 3 times negative 3 is going to be negative 9. Negative 9 minus 8 is the same thing as negative 9 plus negative 8, so try to think ahead on that. Negative 9 plus negative 8 is going to be negative 17, so that's what we're going to put in this box over here. Now x is going to equal 0. This should save us a little bit of time here, so 0, let's substitute it into our expression. So it's going to be 3 multiplied by 0, 3 times 0, then we're going to take away 8. So let's see, 3 times 0, that's just going to be 0. 0 minus 8, that one's a little bit less work. That's going to equal negative 8. So let's go ahead and put that in as the value of this expression when x is equal to 0. Next, we can see that x is 3 now. So we're going to substitute 3 into this expression. So 3, we're going to now multiply by 3. And then let's take away 8 here. Now multiplying first, 3 times 3 is 9. So we're going to have 9 minus 8. 9 minus 8, finally we're out of the negatives here. This is going to be a positive 1. One final time, now x is 6. Let's go ahead and plug that in or substitute it in here. So it's going to be 3, or multiplying this by 6. Okay, and then we're going to take away 8 afterwards. So 3 times 6 is going to be 18. We're going to have 18 minus 8. And 18 minus 8 is going to equal 10. So for this last box, we have 10 here. So when x is equal to 6, this expression would be equal to 10. All right, one final problem here. Mr. Lee is going to Chipotle and looks at the following menu, which we have below here. So it looks like we have some different items. We've got some tacos here, some guacamole, some burritos, some quesadillas, some drinks, and some salads here. So what are we going to do? We're going to go ahead and write an algebraic expression that represents the total cost of buying, let's see here, we have 4 tacos, then we have 2 quesadillas, and then we have 1 salad. So total cost here, let's see here, 4 tacos. Well, tacos is going to be T here. All right, so total cost is going to be adding up the total cost of each of the items together. So if we are buying 4 of these tacos, notice how tacos is T. So we're going to write 4T, or 4 multiplied by T, plus, what else do we have here? We have 2 quesadillas. Well, the price of the quesadillas, we got Q over here, so it's going to be 2 of those. So it's going to be 2 times Q plus, and then we're going to buy 1 salad here. So salad here is going to be S. So you can write 1S, or you can just write S. A lot of times people use a cursive S when dealing with algebra, so it doesn't look like a 5 by accident. Let's take a look at B. For B, it says, let's go ahead and write an algebraic expression, so very similar. That represents the total cost, so very similar, of buying, let's see, we're buying 5 of these burritos, then we're buying 2 orders of guacamole, and 4 drinks. Okay, so total cost, we're going to add up stuff again here. So we have 5 burritos. The burritos is going to be B. So we're buying 5 of those, so 5 times whatever the cost of that is, plus. Then we're buying 2 orders of guacamole. That's G, so we can say it's going to be 2G. Plus we're buying 4 drinks. Now the drinks are going to be represented by D. So 4 drinks, we can go ahead and write plus 4D. Okay, so if you substituted in the prices for each of these, you could then solve that numerical expression to get the total cost here. For C, we're going to go ahead and write another algebraic expression that represents the total change. So again, it's going to be algebraic again, but we're going to see the total change that you receive. You're going to pay with a $100 bill, and then you're going to buy 5 quesadillas. You're going to buy 3 drinks, 6 tacos, big order here, and then 4 burritos. Okay, so if we're writing an expression that represents the change we get, we're paying with a $100 bill, so we should have 100 minus, okay? And let's see, let's go ahead and add up a bunch of stuff here. So we are buying 5 quesadillas, so let's see what that's going to be. For quesadillas, looks like that's going to be Q, so it's going to be 5Q. What else are we buying here? We're buying 3 drinks, I believe that was D, so it's going to be 3 times D, plus 6 tacos, would be 6T, and the burritos should be 4B. Okay, so this right here would be adding up all the cost of all the food together, and we're supposed to be writing an expression that represents the change you get back. So if you give them a $100 bill, you should subtract all the cost of food that you spent, and then you should get the change back afterwards. So this would be a good algebraic expression to write here. All right, let's move on here. Now we're going to go ahead in part D and write a numerical expression that represents a total change you receive. So this is actually, this problem over here is piggybacking off this one over here. So it looks like it's the same exact thing. We're just going to go ahead and write a numerical expression. And so we're going to substitute the values of the prices here. So again, this was our variable or algebraic expression we had a moment ago, but we're asked to write a numerical expression, not to solve it yet, just a numerical expression. So we're going to have 100 minus, and so this is going to be 5 times what's the price of a quesadilla. Looks like that's going to be $7.25. Then plus what? 3 times what's the price of a drink? Looks like it is $2.59 plus 6 of these tacos, so 6 times. Well, how much is each taco? It's $3.89, 3.89, and then plus 4 times the cost of a burrito. I'm running out of space here, so I'm just going to write 4 times the cost of burrito, which is going to be $9.59. Okay, so I know a little strange to kind of rewrite this on the next line here, but hopefully that makes sense. I ran out of space a little bit. Actually, real quick, I'll fix this. Let me just move this to the left and then move this over here. All right, that looks a little better. Looks less awkward now. All right, again, this over here was a algebraic or variable expression. In part D, we're asked to write a numerical expression, so this would be the numerical expression, and we can actually solve this now. So in part E, we're asked to determine the amount of change that you actually receive from the numerical expression that you wrote in part D. So we just went ahead and wrote that. Let's go ahead and just do each of these multiplication problems, right? If you need to write down any of the long multiplication, make sure you do so, but 5 times a 725, that should be, well, actually, let me write this 100 down first. And then I'm gonna go back to using parentheses. So 5 times 725 is gonna be $36.25 for all the quesadillas, plus we're buying 3 of these drinks, but that's 3 times $2.59. That's going to be $7.77 plus, and we're doing 6 of these tacos. 6 times $3.89. That's going to be $23.34. And then finally, we're buying 4 of these $9.59 burritos. So 4 times $9.59. That's going to be $38.36. Okay, so we're going to go ahead and add up all of these prices over here and see what happens here. So $36.25 plus $7.77 plus $23.34 plus this $38.36. So that's going to be a total of, so 100 minus 105.72. Okay, so if we take this 100 minus this 105.72, that's actually going to be a bit of a problem. You're going to get negative $5.72. So technically, if you were writing an answer to this more application-based problem, you should say that this would be a negative 5.72 or negative $5.72. But let's try to talk about this and make sure we understand what this represents. Basically, this means that you would have to order less food because the amount that you ordered exceeds the amount of money that you actually have here, given that you only had $100. So while this answer doesn't get you something realistic because it goes over, this does happen sometimes in real life, right? Where you end up realizing that you don't have enough money for something, so you just have to put something back, or you have to order less of something. So what would be the change? Well, the answer technically here would be negative 5.72, which means that you went $5.72 over budget. That just about wraps up this video on reviewing a bunch of different problems dealing with just expressions, right? So a bunch of numerical expressions, as well as a bunch of variable expressions where you have to make some substitutions first and then evaluate using the order of operations. If you found this video helpful, please consider giving it a thumbs up. And as always, keep up the great work that you're already doing, and I'll see you in the next one.